Good morning, good evening, wherever you are today. Welcome to our second training session related to our Transatlantic AI Hackathon. The German-American Business Association is happy to present this hackathon together with EIT Digital. And we are so grateful to have Intel and Luxonis, our platinum sponsors, who do this valuable training leading up to the hackathon. I'm Michaela Balek, GABA's Executive Director. Today we will hear from Eric Kokaj from Luxonis about the spatial AI camera board that all Transatlantic AI Hackathon participants will receive. And you hear that right. When your project is admitted and you are a team member of one of the about 15 teams that will get admitted to the hackathon, you will get one of these boards shipped to you. So without further ado, Eric, why don't you get started to tell us all about this board and how to use it and yeah, all your secrets.
Hello, everyone. My name is Eric. I'm a depth AI developer at Luxonis, and today I will be presenting Luxonis's depth AI platform and depth AI devices. If you have any questions during the presentation, please feel free to ask them in the chat. And Jay, please ask them during the presentation so they will be still relevant. I was born and raised in Slovenia, so I apologize in advance for all language mistakes that I will make during the presentation. Let's go through what we will be covering today. We will start with a quick intro of depth AI platform. We will cover a couple of applications built with depth AI. We will go through neural inference types that are supported. We will check what's inside our devices. Then we will continue with our hardware, followed by the depth AI Builder API. Then we will quickly cover OpenVINO model conversion, have a couple of live examples with depth AI demo, and finish with a Q&A session. So let's start with a quick overview of depth AI platform. As mentioned in the challenge introduction, we have created depth AI platform in order to achieve a small, light, performant, and inexpensive spatial AI and CV solution on the edge. But what actually is spatial AI and CV, you may ask? It's the capability to get neural inference results in physical space. So, for example, to obtain spatial coordinates of all ripe strawberries in real time. We actually created a demo app for these exact use cases, as you can see on the video. The robotic hand knows where in space the strawberries are, so it knows how and where to move in order to pick the strawberry up. In other words, this is the result that we wanted to achieve, and we have achieved it. You can see the spatial coordinates of the person and the chair on the depth map. Let's go through some of demo applications that have been created on top of the depth AI. Here's an awesome hand tracking demo with 3D visualization. Demo was created by Gax, one of our community members. Demo itself does look really nice, but you may ask, what can I actually do with this? Well, Gax also created two applications on top of his hand tracking demo. First app is playing Tetris with hand gestures. He actually became really good at it, as you can see. And the second app is controlling home IoT devices, such as this LED lamp. Here's a human-machine safety demo. To not harm any engineers, we selected this bottle to be considered as dangerous object. And as my hand comes close to the bottle, the depth AI alerts user about it. In our case, it just displays that I should drink water instead of the soda. And as you can see on the video, we calculate the distance between the soda bottle and my hand. This is another demo app by Gaps, pose estimation with Blaze Pose on the depth AI. You can see pose estimation visualized in 3D space. An application of such capability would be AI-assisted home workout or yoga training device. Both of these use cases are actually already being implemented or prototyped by our customers and users. Here's a semantic segmentation demo. Deep Lab model running on depth AI camera at almost 30 FPS. In this demo, we are cropping the depth map based on the semantic segmentation results, resulting in the middle window. For example, this could be used to estimate surface or, with a few tricks, even volume of the desired object. In this example, that would be. We have license plate detection and recognition demo. It first detects license plate and then performs optical character recognition, so OCR in short, on it to get license plate location and number. One of our customers is a big parking center, and they are creating an AI-powered parking ticket solution based on the license plate recognition. As you can see on the video, pedestrian detection, tracking, or counting is also fully supported by depth AI. An example of use case would be to count people when they leave or enter a shop. So you can limit number of customers that are in the shop, for example, for COVID safety reasons. For privacy reasons, you could also run inference on depth frames instead of color frames. We have gaze estimation. We have gaze estimation demo. This is actually a fairly complex demo as it uses 4 neural network models. More on this later. Application for such gaze estimation capability would be, for example, in self-driving cars to make sure that the driver is watching the road, not their phones. There are many more demo apps available open source that you can check out on our GitHub. Now let's quickly go through the supported types of neural inferencing. We have object detection. Most popular here are YOLO and MobileNet models. There are face and facial landmark detection models, expression models, age and gender estimation, head pose estimation, identification and re-identification of the face, and so on. We have vehicle and license plate recognition. We have already seen a demo app that uses these capabilities. Pedestrian detection and tracking, again, we have already seen this. There's optical character recognition, OCR in short. There's semantic segmentation. We have seen this demo to assist depth cropping. Pose estimation, also covered by our demo app. We can also run stereo neural inferencing. So neural inferencing on both left and right monoframes, and then triangulate the landmarks to get 3D locations of the landmarks. In this case, we are using stereo neural inferencing to get the face landmarks. Now that you have an idea of what you can use our device for, let's take a look at what's inside that AI camera. There's a pair of 1 megapixel global shutter mono cameras, which are used for creating disparity depth frames. In the middle, there's 4K color camera. Other specs are in the description. At the heart of every depth AI device, there's Intel's Myriad X VPU. VPU stands for Vision Processing Unit. Jay has already mentioned this chip in his previous webinar. This VPU is compatible with all OpenVINO models. It has compute capacity of around 4 trillion operations per second. Our IoT devices also have an ESP32 onboard that communicates with the VPU via SPI. ESP32 features Bluetooth and Wi-Fi connectivity. It supports ultra-low power consumption and has a number of hardware interfaces for communication. Since we have already went through some of open source software demo apps, we will now go through our hardware devices. Let's quickly check our hardware designs. So these boards are all open source and you can modify the PCB to your needs. On the left, we have power over Ethernet, PoE in short, designs. You can have thousands of PoE devices streaming metadata to a central server or host computer. Ethernet allows long distances between the host and the device, up to 100 meters. It's also more suitable for outdoors usage due to waterproof and dustproof enclosure. On the bottom, we have two designs that have cameras connected with flexible cables. They are called OFFC. The benefit is that you can select the desired baseline. That is the distance between the mono cameras. When mono cameras are further apart from each other, you can perceive depth at greater distances, but can perceive it at closer range. Then there's OD IoT on the top that is suited for IoT applications as it supports standalone mode, that is running without a host computer. On the right, there's a Depth AI device that has integrated Raspberry Pi compute module on the board. And on the bottom right, we have most popular devices, OAK-D and OAK-1. They are both USB connected devices. Now let's check our pipeline builder. This is the API that lets you build highly customizable pipelines and flows. Here's a list of capabilities supported by the pipeline builder. You can use neural inferencing of OpenVINO models, object tracking, frame encoding of video or still images, lossless digital zooming, edge detection, feature tracking, support for April text, warping and dewarping, stereo depth perception, and now we have added the support of running Python scripts on the device itself, which allows for very complex pipelines to be run on the edge mode, which means without a host computer. And we will cover more on this on the next slide. Also, a few other capabilities that we don't have on this list is the UFC mode. So you can use Depth AI device as a webcam for your Zoom calls. We have 9-axis IMU support that can run at 1 kilohertz. And we also have two-way SPI interface integrated into our firmware, which can be used to communicate with an external MCU, for example, an ESP32. We have seen the pose estimation demo app before from Gaps. This is the block representation of the pipeline running in host mode. This means that the data is constantly streamed back and forth between the host computer and the device. It is streamed to the host for decoding of the neural network results and cropping of the frame to later send it back to the second neural network, which is in this case landmarks detection model. This is the same application by Gaps, but the pipeline is edge mode. So everything happens on the device itself. We just receive landmarks and bounding boxes on the host machine. Processing everything on the device means that there will be less delay or lag, since there are no intermediate transfers between the host and the device. As you can see, we are using script node. This is the yellow rectangle in the middle that is managing the flow of the whole pipeline. It is used to determine cropping configurations of the input image for the second stage node. We have also seen the gaze estimation demo at the beginning of the presentation. This is the data flow representation of the pipeline. At the start, we have a face detection model. We crop the out of the frame and feed it to both landmark detection and head pose estimation models. These two models run in parallel. The output of these models are then used with the gaze estimation model. As a result, we can get the final gaze trajectory and gaze coordinates. Just to give you an idea, this whole app was actually less than 400 lines of Python code. And I have just seen this awesome app. It's from Cortic Technology. And let me showcase. So it lets you build pipelines using Scratch programming language. Cortic Technology actually has a few other really cool projects on their Twitter, so I recommend everyone to check them out. Let's check how to get a random model converted so it can be run on the Depth AI device. In order to get a model running on Depth AI, you need a dot plot representation of the model. Let's say you have a neural network model in TensorFlow. First, need to use Model Optimizer to obtain OpenVINO's intermediate representation, ER in short, of the model. This includes .xml and .bin files. After getting those, you can use compiler to compile the ER format into the needed blob. If you'd like to deploy a model that was trained using a different tool, for example, PyTorch, you can even do that. And first export the model into Onyx representation, and then follow the steps above. Here, I would just like to note that some layers are not actually supported either by OpenVINO or by the VPU, so the Myriad X chip itself. If that happens, we have to replace the unsupported layers with supported ones in order to get the model running on the Depth AI. This whole process is quite complicated, so we have created, especially for the beginners. That's why we have created open source tool called Block Converter. It has web interface on the left, and it's also a Python package installable by pip. It's used extensively in our experiments. You can use it to simply download the block of more than 100 pre-trained models from OpenVINO Model Zoo. I believe Jay will talk more about OpenVINO Model Zoo in his next webinar. So I would also like to showcase the Depth AI demo. So what actually is Depth AI demo? Depth AI demo is a simple to use and flexible Depth AI demo application. By default, it uses MobileNet for object detection and displays bounding boxes and classes to depth and color frames. There are several other available models out of the box, as shown on the left. The Depth AI demo application can be found in the Depth AI repository on our GitHub. So here are some examples of using Depth AI demo. Let me go out of PowerPoint. Let's copy paste it. So this command should run the vehicle detection on the video. As you can see, it's not synced, but we could do that as well. Let's go to the second example, which should detect pedestrians on the video, and it will also count them. We are getting about 12 FPS, and on the left side, you can see number of pedestrians detected in the frame. Now let's check the final YOLO V3 example. YOLO V3 is actually a really large model, so it will run slowly, but it will be very accurate. So this will be actually live now. You can see I have my cup, and it should detect cup and me, and wine glass as well. Here you can see that it displays spatial coordinates of each of these detected objects and the label and confidence of the object that it detects. On the depth frame, we can actually also configure disparity confidence and bilateral filtering. So it's smoother. And let's quickly showcase how it runs just by default. So it will run mobile SSD model, which is much faster than the YOLO V3, the full YOLO V3. And as you can see, much better FPS. And also the depth frame looks really nice here. And as you can see, the accuracy isn't as good. And I would just like to mention, so on GitHub, we have a lot more depth AI experiments that you can check out. I'll just go through them quickly. So we have seen the gaze estimation. Here you can see sub-pixel and the point cloud of the depth. We have age and gender demo. We have OCR, pedestrian re-identification. We have mask and no mask detection, which is actually trained by our open source ML training example. We have social distancing example, a MJPEG and JSON stream, stereo neural inferencing result visualizer. So this is in 3D, visualizing of landmarks. We have people counting, people tracker. So a similar example to the one I just showcased before. But here you can also see how many people went upwards or downwards. We have point cloud projection, RGBD and point cloud, and also host side filtering. And you can also run multiple devices per host. So this actually concludes our presentation. Does anyone have any other questions? I believe Jay will have next webinar next week, which with the title of Deep Dive into Intel Distribution of OpenVINO Toolkit and OpenVINO Model Zoo.
Great. Thank you, Eric. This was fantastic. I'm amazed what you can do and have already done. And I'm sure there are so many more things that can be done with this AI depth and everything else. And I hope people can be really creative with this. I mean, this looks like it really triggers your brain cells to start thinking about what else can be done.
Countless of possibilities.
Yeah. definitely. Let me see. I do not see a question at the moment. We can also, if you like, we can give you the permission to talk directly if you raise your hand.
Okay.
And ask questions directly in the audience. That's fine as well.
Yeah, sure.
Okay, Jay, would you like to add something to this, since you already gave the initial presentation last week and have a few more coming and presumably have worked with, maybe not with the board directly, but at least with Luxonis a lot and seen all these exciting things that are already happening?
I would love to, actually. I think now would be a great time to show, maybe remind folks about a couple of great articles on Luxonis's website. So if you'll give me a moment, I will share my screen. Okay, are you able to see my screen?
Yes.
Okay. I'm going to start here. Are you still able to see my screen on the presentation?
Yes.
Okay. So in last week's presentation, we talked about the workflow. Am I in full mode or is it in like a presenter mode?
We actually see the presenter mode right now.
Okay. I'm trying to get this toolbar to move so I can change the display settings. Okay, is that better?
That's perfect.
Okay. Yeah, so last week we talked a bit about the workflow and using Luxonis devices, and Eric can pipe in as well. But the workflow is, they've greatly simplified the workflow because it's a very distinct device to use. Our OpenVINO toolkit is a broader toolkit with more capabilities and deployed to a lot of other different types of devices with different architectures like CPU and GPU. But with the VPU and specifically with Luxonis devices, you have a very simplified workflow. You use a pre-trained model. You can bring your own trained model, and you can use the OpenVINO toolkit either in our Intel Dev Cloud for the Edge to convert it to FP16. That's the format that the VPU needs and this Luxonis device needs. And it creates the .bin and .xml intermediate representation file. What that means is it's a translation of a trained model so that Intel's architectures understand it. Or you can use one of the trained models from our Intel Open Model Zoo. We have public trained models and we have Intel pre-trained models as well. You then use OpenVINO to create the compile the inference engine blob using the myriad compile command. You can do that on your own laptop if you install OpenVINO, or you can do that in our Intel Dev Cloud for the Edge as well, where OpenVINO is installed. And then you set the blob path and you load it into the Luxonis device and you observe the action. Now there's two articles on Luxonis's website that are very important and instructive to doing this. So there's one on running Luxonis's default models and one as well as to run Intel's pre-trained models. Let me get out of presenter mode here. And so just for a moment, I'm going to paste those into the chat. The first one is Luxonis's default models. And the second one are using Intel pre-trained models. Okay, so now this article is using Luxonis's default models. It's a very quick tutorial. You can follow it here. Talks about how to run the depth AI model. This is a Python instruction. In this case, this article talks about the face detection retail model. It describes the model arguments that are passed. You can then, in terms of running that model, the Python command talks about the particular model that's used, a MobileNet V2 SSD. Single shot detect is what SSD stands for. And I think this model is trained on persons or animals, a number of classifications, vehicles, and things you might find indoor. I think you could run this model on your laptop. You can then run this model on the device. And you can see the wonderful picture of Eric. So Eric, I think you must have been the author of this article. Is that correct?
Yes, that's correct. We just updated it a week ago or something like that.
Okay, great. Yeah, you can see it recognizes his face. And then there's other models you can try. So segmentation models, those are kind of models where it's typically an overlay of different colors. A bitmap is what it's called, of different areas of an image. Face detection, pose estimation, you'll see that, and you can do that actually on yourself, aiming the camera at yourself, and sort of does your head, neck, arm, and upper torso shape and moves as you move. It's kind of a fun tutorial. So lots of person related, so pedestrian, person detection, vehicle detection as well. So really encourage you to try this out. And then you can also augment this model with 3D positioning. And early on in this webinar, Eric showed you kind of like how 3D positioning is used in conjunction with AI. Okay, so the other article describes how you might want to use OpenVINO and use the Intel Open Model Zoo. So the first article is more sort of out of the box, using depth AI and default models. And this one is how to use Open Model Zoo. So you install OpenVINO on your local laptop. You can also use the Intel Dev Cloud for the edge. Some Python commands. So all the code's sort of written here in these gray boxes, and where you'll find the models. It's downloaded the FP16 version. Remember to use the FP16 version. Last week's webinar described how there's different versions of models because there's different sizes of models that can take advantage of different architectures and lengths of essentially byte strings. FP16 is importantly is the one you want to use. This talks about the model architecture and the weights and biases of the .bin, the .xml, which is the translation of the model to understand so that the Intel architecture can understand it. You can compile the model into the inference engine blob using their compile tool, and some setup instructions to set up the OpenVINO environment using the compile tool, and then running the compile tool on your model. In this case, it references that same model, face detection retail 0004. And this is the command. And then it talks about what you'll see. So a little bit further down, talks about how you can download models. OpenVINO comes with a tool to download a whole host of all of those, about 200 pre-trained models. So easy to grab, download to your computer, compiling them as well. And yeah, so It's a very simple article, great way to get started. Anything you'd like to add, Eric?
So as mentioned below, at the bottom of the page, it's much easier to use blob converter to simplify this process significantly. So it will compile and convert the model on our server, and then you can download it from the server with this command line tool or Python package, the blob converter.
Right. We've really given you a lot of different ways to be able to perform a number of the same things. So Depth AI, so you might want to Google Luxonis Depth AI. You'll find all their articles here, and it's well navigated on the left side nav bar here, tutorials, demo scripts, and using modules, C++ or Python. So yeah, very easy ways to get started.
Yeah, great. Thank you. I don't see any other questions at the moment. I just had one on my own, wondering how long do you think it takes to train on something new? So, I mean, you've shown all kinds of examples already and may have an idea what people should expect in terms of time. And of course, I'm aware it will depend on the object or on the type and how fast it moves or whatever, as well as on the skill, obviously, or the familiarity with all this. But I also have in the back of my head that there are lots of things to do for everyone who wants to try this out beforehand, right? And can try and play around with it and maybe try to train on something and so on. But just as an idea, what to expect, how long this process may take.
Yeah, so I would say, and Eric can speak into this, so Luxonis has made this extremely easy. It's why we selected to partner with Luxonis and their device and their Depth AI software stack easily complements OpenVINO, and OpenVINO just offers a whole additional ways and range of capability. Those who are selected to participate in the hack and then receive the Luxonis device, I mean, I think typically, like Eric, it maybe takes 30 minutes to an hour to really get going with Depth AI and the Luxonis device, because there's not any, OS installation or compiling of an OS and loading it. All of that's very easy to use. Between now and the hackathon starting, it's why we're hosting these training sessions for you, because you have all of this time now to really explore both Luxonis Depth AI, but also OpenVINO, the Intel Dev Cloud for the Edge, download OpenVINO. You can really get started with your own PC in using the integrated CPU and GPU with OpenVINO itself. While the hack will use the Luxonis device, it really helps give you an understanding of how to use the power of AI and navigate this. Eric, do you have anything to add?
Yeah, so we also recommend using OpenVINO's inference engine before actually converting the ER model into the blob. So first you make sure that the model is running in the ER format, and when you configure the decoding and everything works as expected, then you move forward to creating a pipeline that suits your application and to convert the model into the blob.
And we'd love to communicate with you on Slack as well when you have questions.
Yeah, and once you have registered on the hackathon registration page itself, then I believe the Slack registration will come right after that. So that means then you can communicate with everyone, including Jay and Eric, about questions you have. All right, great. Looks like we don't have any more questions. This session is recorded, so you can review it and you can send it to everyone else who may be interested, to potential team members, perhaps. And then let's get started. Let's get going. And I hope I see you next week, as well as on the hackathon.
Thank you, Michaela. Thank you, Eric. Thank you, Ivan.
Yep. Thank you, everyone.
Thanks, everyone, for the time.
Thanks for everyone attending.